In this lesson, we're going to talk about adding, subtracting, and multiplying radicals. So what we're going to have to do is simplify radicals and then add or subtract them based on the rules that we can use to do so. All right, so we have to kind of consider radicals of like and unlike terms. So over here, these are all like radicals. So if we see we have the same roots here, those would be considered like radicals. If we're looking at these over here, these are not the same root. We have a square root and a cube root. We have a square root 6, square root 7. These are not like radicals. So similar to like terms, they have to match completely. Like terms have to have the same variable and same exponent, and radicals have to have the same index and same number underneath. Okay? So a couple examples kind of starting off here. Let's look at A. So we do have like radicals, okay? We need to know the number in front of this radical. If you don't see a number in front of a radical, it's kind of implied. Just like if you have an x, that's a 1x. We usually don't write the 1. If you need to write it here to help you out, that's fine. Okay, so let's do the easy part first. 6 plus 7, that gives us a 13. And now we have this radical and this radical. So since they match, we can add our coefficients, okay? So a positive 4 and a negative 1 gives me a plus 3, and we just write the root 2 back out because that was what told us that they were the like radicals, okay? So that one is 13 plus 3 root 2 because we can add this with this because they match, okay? So this one should be similar. Let's take care of the easier parts first. So we have an 8x that's all by itself. We can't put this with these because those have radicals. So 8x is the first thing. And then minus 3, that's the easy part. We couldn't put anything with the 3 because there is no other constant. So now we're looking at this and this. And I highlight the sign with that just so we know if it's adding or subtracting. So the radicals match. They're both cube root x. We have a 2 and a 4, so we can add the 2 and the 4 because the radicals match. So this would be plus 6 cube root of x. And generally, we write the radicals last. That's just good practice because those have fractional exponents. So write the radicals last. So like this one, we have the 3 root 2 in the end. This one, we have the 6 cube root x in the end. Okay? So now we have something like these two, where this does not match that, okay? So we have to think about what we can do in order to get them to match. Well, if we got the 27 here, okay, some things that we can do with that, or the one thing we can do with that is break it down. So break the 27 into a 3 and a 9, and that 9 breaks into a 3 and a 3, and then we simplify that. So since it's a square root that's implied there, we're looking for a group of 2. So this would turn into 3 root 3. And let's put that back over here. So we have square root 3 plus 3 root 3 because we simplified that root 27. All right? Now remember the number in front here is just a 1, and we do have like radicals here and here. So 1 root 3 plus 3 root 3 is 4 root 3, and we can stop there. Okay, so these scenarios you're going to have to simplify the radical, which is kind of the way we're going to have to do this the rest of the way, the rest of the lesson here. Simplify the radical and then add them, okay? In B, you're going to have to simplify both of those radicals and then see if you can add them. So pause the video, simplify both of those radicals, and see what we get in the end, okay? All right, so root 20, if we break that down, 20 is we can do a 4 and a 5, and the 4 breaks down to 2 and 2. So the 20 is a 2 root 5. So the root 75 breaks down to 5 and 15, and the 15 breaks down to 3 and 5. So we have a pair of 5s. That is 5 root 3 for that one. Okay? And then we're looking at this. That's a square root 5. That's a square root 3. They are not like radicals. So we cannot add these together. This is just the answer. So when you're writing your answers out, you have to have them in simplest form. So we did have to reduce these, or we had to simplify these, even though they didn't add in the end, okay? So let's check C. Same way, if you want to pause the video and get started on it, we can do that. Otherwise, we'll just get going with it. So 12, I'm just going to leave all these here and break them down. So 12 is 2 and 6, 6 is 2 and 3. We have a pair of 2's, so this turns into 2 square root 3. 28. Okay, you can do a 2's if you want to, or it's 7 and 4. 4 is 2 and 2. So we have a pair of 2's, so this would be minus 2 root 7. And then the 48, we break that down to 24, to 12, to 6, to 3. So we have a pair of 2's here, a pair of 2's here. So remember, when you have two pairs that are coming out, those would multiply. So this would be 2, all right, this would give us a 2, this would give us a 2, so that's 4 in the front. So plus 4 root 3. And then we look at our radical. Do we have anything we can put together? This goes with this because they match. So 2 plus 4 would be 6 root 3, and we have minus 2 root 7. Okay? So sometimes we can add them together, like we did in C here, and like we did in B up here. You couldn't add them together, but we had to simplify them. Okay? So let's try a few more. So pause the video, work through these, and then come back for the answers. All right, so 24, break these down. 2, 12, 2, 6, and then the 6 is a 2 and a 3, which doesn't help us simplify anymore. So we have a pair of 2's coming out. So if we have a 2 coming out or a pair coming out, and there's already a number in front, you're going to multiply those. So 2 times 5 would be 10, and we put those back underneath. So 10 root 6. And then we break the 54 down, so 2, 27, 3, 9, 3, 3. All right, so looking for a pair of numbers here. We have a pair of 3's. Those go back underneath, so this would give us a 3 in front and then a 6 underneath. And then we look here and here, those radicals match, so we can put those together. So that'd be 13 root 6. All right, so do the same thing with B and C. We got cubes. If you want to work on that, you can. So for B, break these down. 5, 9, 3, 3. We got a pair of 3's with the 4 out there already. So this will give us a 3 right here. This will give us our 4, so that's 12 in front. Break down the 80, so 8 and 10. 8 is 3 2's, 10 is a 2 and a 5. We have a pair of 2's there, pair of 2's there. Okay, so those two pairs give us a 2 in front twice, which is 4. We have 4 root 5 for that. 20 is 2 and 10, and then 10 is 2 and 5. We have a pair of 2's. Those give us a 2 in front, and the 5 goes back. All right, so now look at our radicals. We have root 5 here, root 5 here, root 5 here, so we can put all these together. So 12 minus 4 is 8, plus 2 is 10. So this one is 10 root 5. So the general idea with these, simplify the radicals as much as you can, and then when you get to that point, you look at the stuff underneath the radicals to see if they match. If they do, you can add them. If not, you have to leave it. All right, last one here for this slide. So break that down, 3 and 9, 3 and 3. So this is a cube root. The index is 3, which means we need 3 of a number to simplify. So we have 3 3's, so it's cube root 27, just a 3. And you could have known that just by knowing your perfect cubes, or break it down like we did here. 81 is a 9 and a 9. Those break down into 3's. Looking for 3 of a number for a cube root. So the 3 would come out, that 3 would go back underneath there. And don't forget the index. You can't forget that because it's important when you're adding and subtracting radicals that the indexes match. Okay, now we're looking at these. We have a radical here, that's a cube root 3, and a radical here, that's a cube root 3. So we can put those together. This is just kind of on its own. So negative 3, positive 7 is a positive 4, and then we're going to write that cube root 3 back in there. Okay, so cube roots work the same way as square roots, except we're looking for 3 of a number. And again, if you have a number in front already, like this, whatever we bring out from the 81 has to multiply by that one. So don't forget how that works. All right, let's try these. So we're trying to simplify these with cube roots here. And then B, we have variables. All right, so if you want to give these a try, you can pause the video and then come back for the answers. Otherwise, I'll keep working through them. So we have cube roots, so we factor tree them if we need to. This one, we don't necessarily need to factor tree just because it is a cube root of 8, which is a perfect cube. That turns into a 2. 54, we'll cube root, or we'll break that down. So 2, 27. 27 is 3 times 3 times 3. So we have a triplet of 3s. So that comes out. The 2 goes back. All right, so 3 cube root 2. And then over here, we can't do anything with it, so we leave it. All right, and now we look at this to see what we can put together. We have a cube root of 2 here and a cube root of 2 here. Those match, so we can put these together. So up 2 minus 4 cube root of 2 for that one. All right, and you might feel like you can put this 2 with this 2, but remember we can't because this is a cube root and this is not. That's a regular 2. Okay, so let's try it with variables. All right, we have square roots. Remember how to simplify square roots of variables. So square root of x squared, this just turns into an x. And this, remember we're looking for groups of 2, so how many groups of 2 can we get from there? That's another, just a plain x. And we can't do anything with the y, so it stays as the square root of y. And then back here, we have the same x squared, or x square root y. So now when variables are involved, we really have combining like terms completely. So we have to have matching variables in front, matching variables inside in order to put things together. And if there is no coefficient, you put a number in front to help you out. Okay, so we can put this together with this because they have an x root y. Those match completely. And since one's a negative one, the other one's a positive one, they cancel out and you just get an x in the end. Okay, so we really need to pay attention to like terms when we're doing this. We have to have like radicals and like variables. Okay, for C, cube root here, so we're looking for groups of 3. So how many nice groups of 3 can we get out of x to the 13th? Well, we can get 4, that would be 12 of them, right? And then we start putting things back. So if I'm taking 12 of those, there's an x left, and I can't do anything with the y's because I don't have 3 of them, okay? So I have x to the 4th cube root xy squared for this thing on the left. Then the one over here, let's simplify that. So how many nice groups of 3 of x's can we get? Just 1. Okay, cube root. And then there's 1 x left. I can get 2 nice groups of that. That's y squared. And then we have, let's fix that. And then we have 2 of those left. Okay, and so we're putting this with this. Okay, so we have to look, do we have the same matching variables on the outside? No, we don't. We have the same matching variables inside, here and here, but the ones on the outside don't match. So we can't do anything, and this is just the final answer. So we just simplify it and leave it. Okay, so we have multiplication and then simplifying, and that should finish the lesson. All right, so if I'm multiplying, I have to have the same radical, and I can multiply the things underneath. So since this is a square root here, I'll have 48, and remember when I multiply variables, I add the exponents, x to the 9th, and we're still in a square root. All right, so let's break that 48 down to 24, and that is a 2 and a 12, and a 2 and a 6. 6 is a 2 and a 3. So we have 2 groups of 2, which gives us a 4 in front. Okay, and the 3 back underneath, and then we break down the 9. So how many nice groups of 2 can we get from that? Should be x to the 4th, x left underneath. Okay, so the idea is to multiply first and then simplify later. Okay, so we multiply the 2 and the 4, which gets us an 8, add the exponents, and then we take the cube root. And look at this, this is a nice cube. So cube root of 8 is a 2, cube root of x to the 3rd is just an x. Okay, and then the same thing for C. So what you can do with this, if you don't want to multiply 4 and 16, you can just start breaking these down right away. And and then you can look for groups of all of these numbers together, okay? So I want 4 of a number, which I got 4 of a number right there. So since we have those 4 2's, that gives us a 2 in the front. We're looking at these factors all together because we'd be multiplying the 4 and 16 together anyways and breaking them back down. So that's why we're looking at these factors. So we have 2 coming in front, comes from those 4 2's. And then we're going to write our radical here because we're putting stuff back underneath there. So those 2 go back underneath there, which would be a 4. And then we're looking at x to the 17th. We can kind of write those off to the side if it's kind of hard to see it in our brain. We got y to the 23. So we're looking at groups of 4 from here. All right, so that's me putting these together. Groups of 4. So how many groups of 4 can I get from x to the 17th? It'd be 4 of them, which would be 16 from there, right? X to the 16th is 4 nice groups, so we got 1 left. How many groups of 4 can we get from y to the 23rd? That would be 5 nice groups, because that would be y to the 20th, and then there are 3 left, all right? So that's how we simplify that one. Now, kind of going back a little bit, we could have just done 16 times 4, and that would have been a 64. And we'd be doing 4th root, 64, x 17th, y to the 23rd. But the method that I used with the numbers is a little bit quicker if you're looking for efficiency. And if you're looking to do it without a calculator. Because 16 times 4 is 64. And then you would do the same thing here, you break it down. Okay? So let's try a couple with multiplication again here. Now this, since we have a minus in between these two, that is going to be a distributive property. And then down here, we have technically a binomial and a binomial. So that's going to be FOIL down here. Okay, so this is where it gets a little bit more difficult with both of these because we have to remember our properties of multiplying radicals. So if I'm taking this and distributing it through, we can do that because they are both a square root. Since they're both square roots, we multiply this stuff underneath. So 2 times 8, 16, x times x, x squared. And those still stay underneath the radical. The radical doesn't just cancel because they're both square roots. Okay? So then the next one, if we multiply the 2x into the 50, that is a square root 100x. And I hope that you recognize we have some perfect squares going on here. So now I simplify this. So square root of 16, or if I break the 16 down, you'll figure out that'll turn into a 4. And how many groups of 2 of the x's can we get? Well, just 1. So square root 16x squared turns into 4x when we simplify it. All right, and then over here, simplify this down. Square root of 100, that's a nice 10. And the x has to stay because it's not a perfect square. Okay, so that is that one. So we have 4x minus 10 root x for this question. Okay, so multiply the numbers underneath the radicals and then simplify the radicals down. All right, so FOIL here, and again, kind of looking ahead here, this is also going to be a FOIL because that tells me I write it out twice. Okay, and we'll get there in a second. So FOIL is first. So square root x times square root x, that's square root x squared. Outer, so this would be a minus square root xy. We're multiplying underneath the radical. Inner, same thing, minus square root xy. And last, so square root y times square root y, this will be a positive because it's 2 negatives being multiplied. Positive square root y squared. And then we simplify things down. So this turns into an x. So this has got a 1 in front of it. And those match. So we can put those together. So it'll be minus 2 square root xy plus square root of y squared is just a y. Okay? And then you don't have to do the x squared and the y squared part because if you remember the property of radicals, if I'm multiplying the same thing by itself in a radical, radicals cancel out and I just get what's underneath the radical. Okay? So with that being said, you might want to do this here Okay, so this is what you cannot do. You might think that you can just distribute a square. Okay, but you can't do that here because the minus does not allow you to distribute a square. You can only distribute squares when you have multiplication going on. So that is not allowed here. So what you have to do with this is you write it out twice. Alright, there's the first time. 2 square root 6 minus square root 3. And there's our second one. Okay, because anything squared, you have to write it out twice. And then we're doing what we just did up here, we're foiling. Okay, so now we have 2 root 6 times 2 root 6. And we multiply the stuff in front together and then the stuff underneath together. So this would turn into 4 square root 36. And you could say that that's a 6 right here if you wanted to, but we'll come back and get it. And then this one is going to be minus 2 goes in front because there's no other number in front here, root 18. And then we have another one here, so it's minus 2 root 18. And then square root 3 times square root 3 is positive. I'll just keep going with this, square root 9. And now we simplify things down. So this is simply a 6. This is simply a 3. So right here we're going to have 24 minus, we can put those two together because they'd match radicals, so minus 4 root 18 plus 3. And we have to put the 24 and the 3 together. So final answer for this one is 27 minus 4 square root 18. Okay? So remember, anytime you're squaring something with a plus or minus in it, it's got a FOIL. And then this is how you FOIL radicals. So if you need a review on that, rewind the video and watch it again. Okay? Your assignment's down here. You'll have a worksheet that has those. Thanks for watching. If you enjoyed the video, please give me a thumbs up and a like.